Okay, today we're going to be talking about prime factorization. This is another page that goes on sideways. Doesn't matter which side you put it on. And this is prime factorization. And prime factorization is page 13 in our notebook. And I just want to remind you that you should be putting this in your table of contents every single time, title and on what page number. Okay, so I'm going to turn it. Every number has its own unique set of prime numbers. When you break a number down to only prime numbers, it's called prime factorization. There are two methods, factor trees and the ladder method. Okay, so factor trees are more common in elementary school. I'm pretty sure that we've all seen our factor trees. That's when you break a number down to two factors. So think about 27. Two numbers that I could multiply together to get 27 would be 9 and 3. Now, since this is prime factorization, I want to break it down to only prime numbers. 3 is a prime number, so I'm going to go ahead and circle that. 9 is not a prime number, so I'm going to continue to break that down. 9 can be broken down to 3 times 3. Both of those are prime numbers, so I'm going to circle. And what that means is 27 is equal to 3 times 3 times 3. Now, in the 5th grade, that might have worked, but in 6th grade, we know what exponents are. So we could say 27 equals 3 cubed. And this would be our answer. I know that it's true because if I multiplied 3 3 times, it would give me 27. 3 times 3 is 9. 9 times 3 is 27. So this is unique to 27. No other prime factorization will be 3 cubed. Not unless it equals 27. Okay, let's try 81. 81, let's break it down to 9 times 9. Neither of those are prime numbers, so we're going to continue to break them down. 9 can be broken down to 3 times 3. Three is a prime number, so I'm going to go ahead and circle those. So 81 equals 3 times 3 times 3 times 3, which we know we can make 3 to the 4th power. Okay, so you can see we are pretty much just breaking each number down to only prime numbers. Now the ladder method is something that we like to use a lot in 6th grade. The ladder method is kind of like upside down division. So if I'm taking 28, I want to think about a prime number that I can pull out of 28. And I just start with our smallest prime, 2. Is 28 divisible by 2? Yes. So I put a 2 on the outside. 28 divided by 2 is 14. So if 14 is prime, we will stop right there. If it is not prime, which 14 is not, we put another ladder. 14, I can also pull out a 2. 14 divided by 2 is 7. Is 7 a prime number? Yes. So 28 equals 2 times 2 times 7. And something I didn't mention over here was that you always start with your smallest numbers and then go into your biggest numbers. Once again, we can use exponents. So 28 equals 2 squared times 7. Okay. 39. 39 is not divisible by 2. It is divisible by 3. 39 divided by 3 is 13. Is 13 prime? Yes. So 39 equals 3 times 13. And that is your answer.